All right, let's talk chip design. In this world, you've basically got two main ways to make sure a chip actually works before you build it: IP verification and SOC verification. Now, these aren't just job titles. They're totally different ways of thinking, they need different skills, and they lead down different career paths. So today, we're going to break down exactly what they are and figure out which one might be the right fit for you.
I mean, really think about that for a second. How on earth do you test something with billions of tiny parts before it even exists in the physical world? Getting this right before you sink millions of dollars into manufacturing is, well, it's everything. This one massive challenge is the entire reason this field of verification exists, and it's what we're diving into today.
So here's our game plan. First, we'll start with a really simple analogy to get our heads around all this complexity. Then, we're going to define what IP and SOC verification actually are and put them head to head. After that, we'll look at what this all means for your career. And finally, we'll zoom out to see the big picture and why this stuff matters so much. Okay, first things first. To make sense of this incredibly complex world, we need a simple, powerful way to think about it.
Yep, we're going to think about chip design like building with Legos. Seriously. This one simple idea is the perfect way to visualize the two different philosophies of verification. So just keep this image in your mind, right? You've got testing the individual little bricks versus testing the giant, fully assembled starship. This one concept is going to make everything else click into place.
So let's start with those individual Lego bricks. This is the world of IP verification.
In the chip world, IP stands for intellectual property. You can just think of it as a pre-designed, reusable chunk of circuitry that does one very specific job, like a USB controller or a memory interface. In our analogy, this is that one single, highly specialized Lego brick.
And IP verification? That's the super intense quality control for that single brick. Does it follow all the rules? Is it perfectly made? Can it handle every bizarre, stressful situation you could possibly throw at it? You're testing this one piece in total isolation to guarantee it is absolutely flawless.
Okay, so we've perfected our individual bricks. They're perfect. Now it's time to build the masterpiece. Welcome to the world of SOC verification. SOC stands for System on Chip. This is the whole shebang, the finished product. It's where you've taken hundreds of those individual IP blocks and plugged them all together. It's not about the bricks anymore. This is the complete Lego starship.
So, SOC verification asks a totally different question. It's not, is the brick perfect? It's, do all these perfect little bricks actually play nicely together? Do the engines connect to the wings properly? Can the cockpit talk to the landing gear? You're not checking the brick itself anymore. You're checking the connections and how the whole system behaves.
So you can see we have two very different jobs, but both are absolutely critical to making a chip that actually works. Let's put them side by side and really see where they differ.
Now, what's so telling about this is how clearly it lays out the trade-offs. IP verification is focused, it's deep, you work on one block, and when there's a problem, debugging is relatively isolated. SOC, on the other hand, is broad and way more complex. You're looking at the whole system, where a single bug could be caused by 10 different things all interacting in some weird way. The scope just isn't on the same planet.
And that huge difference in scope, it translates directly to the skills you need. Now notice that both roles need you to be a master of System Verilog and UVM. That's just your bread and butter, no getting around it. But here's where the paths diverge. For IP, you need insanely deep knowledge of a specific protocol. For SOC, you need a strong grasp of system-level architecture and C/C++ skills to deal with all the firmware.
This quote just nails the mindset for each role perfectly. IP verification is about depth. SOC verification is about breadth and managing chaos. So who are you? Are you the person who wants to become the world's leading expert on one very specific thing? That's the IP path. Or do you love wrestling with a massive, complex system where anything can happen? That's SOC. Okay, with all that in mind, how do you actually build a career in this field? Let's map out a path that really works.
Okay, so here's a huge piece of advice you'll hear from pretty much everyone in the industry. Start with IP. And the reason is simple. You build an absolutely rock-solid foundation. You master your tools, you master your debugging skills, all in a controlled, focused environment. Trying to jump straight into the chaos of SOC without that, it's like trying to build that massive Lego starship without even knowing how the basic bricks snap together.
Let's get specific. At a company like Intel, which builds its business on these monster server and PC chips,
They expect their IP engineers to be the experts on a protocol like PCIe or DDR. For their SOC roles, they need people who are great at system-level debug, and here's a key thing for them, they want you to understand how the design you're testing now will actually behave on the real physical silicon later.
Now compare that to a company like Qualcomm. Their entire world is mobile SoCs for your phone. So because everything is about battery life, low-power verification is a huge deal, even at the IP level. Then at the SoC level, it's this crazy puzzle of integrating a CPU, GPU, AI blocks, a modem, and making sure that whole system works perfectly in the real world inside your phone.
And then you've got a powerhouse like NVIDIA, the leader in high-performance computing and AI. It's no surprise they demand a deep understanding of architecture, even from their IP folks. And for SoC, it's another level. You have to understand how the chip talks to the operating system, how software drivers work, and how to hunt down performance bottlenecks. For them, performance is king.
And all these different priorities, they show up right there in the job interview. An IP interview is going to test your concrete knowledge. They'll say, hey, code this UVM component. An SoC interview, on the other hand, tests your thinking process. They'll give you a problem like, the system won't boot. It's a black box. Where do you even start? One tests what you know. The other tests how you think.
Okay, let's zoom all the way out. We've been deep in the weeds on the technical stuff, but where does all this verification work fit into the global economy?
The semiconductor market is just massive. We're talking about a market that's closing in on $1 trillion. It is the literal foundation of our entire digital world, and every single dollar of that value depends on one simple thing. The chips have to work.
Now, check out this breakdown. The actual selling of physical chips makes up almost the entire market, right? The services we've been talking about, IP licensing, verification, they look like these tiny little slivers. But here's the kicker. A single bug, one tiny mistake that gets through, can cost a company tens of millions of dollars to fix. They have to do a respin, which is basically a do-over. So without that crucial tiny little sliver ensuring the quality, that whole $800 billion tower collapses. It's the linchpin holding everything together.
So, we end right back where we started. You've got two paths to the exact same goal, a perfect chip. One is a deep, focused dive into the tiny details of a single, perfect component. The other is a broad, sprawling journey across a vast, interconnected system. So the only question left is, which puzzle will you solve?